All right, 10-4. This is the last lesson before you guys take your test on Monday. You guys are taking your test Monday. All right, inscribed angles and intercepted arcs. This is the last lesson before you take your test, and there is specific rules in here that you have to remember. And with practice, you'll eventually memorize it. It's not as long as the formulas you had from the previous test, but these ones should be pretty easy if you practice them. All right, inscribed angles, you have to know what that is. An angle whose vertex is on a circle and whose sides contain chords of the circle. So when you're looking at this, inscribed angles are angles that create two chords and their vertex touches the side. You're going to see the difference between a central angle and inscribed angles. Okay, inscribed angles basically go across the circle. The arc that lies between two lines, rays, or segments. Okay, this is the arc that you're going to be using when you're looking at inscribed angles. All right, so looking at this is the rule, this is the formula, this is what you have to remember. It's not hard, and I'm going to draw both of them out for you. So the measure of an inscribed angle theorem. The measure of an inscribed angle is 1/2 the measure of the intercepted arc. What does that mean? Please pay attention to this and write it down because you will have to know this, and I will definitely highlight them so you can see which one I'm doing. So the first one, I'm going to go ahead and draw it in blue. This is what it's talking about. My angle. So here's A, B, C. It's saying the angle, the measure of angle ABC is half the arc AC. So what that means is, if this was, let's say, 60 degrees, how would I find X? Good. So in order for me to find X, what you have to do is take that 60 degrees and divide it by 2, and what would I get? So X equals 30 degrees. Okay, there is a difference between the one in blue and the one in purple that I'm going to draw. So now look at the one in purple. Here's my circle. I'll do it this way. Let's say this is 50 degrees right here. If this angle is 50 degrees, what is the measure of my arc? Good, and how would I find that? Good, now I'm taking that 50 times 2. X is going to equal 100 degrees. Please understand that these two are different. Shh, boys, stop. These two are different than if I gave you a central angle. If this central angle is 45 degrees, what is this arc angle? This is 45 degrees. Please don't get these two or these three things confused. So if it's at the center, it's the same. But if it's an inscribed angle, either you're dividing it by 2 or you're multiplying it by 2. So please understand the difference. Questions on this? Again, with practice, it'll be easier. Yes, Matthew?
Wait, so what's the difference between the blue one and the purple?
So the difference between the blue one and the purple one was for the blue one, I was solving for this angle. But for my purple one, I was solving for my arc. So the blue one I solved for the angle. The purple one I solved for the arc. And you guys will see this on your test, multiple of these, but they're kind of drawn a little differently. So when we get to the examples, that's more of what you're going to see on your test. And you'll have practice with this on the homework. All right, so looking at this one, okay? If two inscribed angles of a circle intercept the same arc, and I'm going to show you what that means, then the angles are congruent. So they're saying 1 and 2 are going to be congruent because this is my arc. Look at where my arc is and look where my inscribed angles are. This is my angle in blue. Okay, so if you're looking at it, it's starting at one end of the arc, coming to the other end of the arc. And then this is my other angle in green. So here's that one, and here's another one. If you're looking at it, they're both sharing the same arc. So because they're both sharing that same arc, both angles are going to be the same measure. Okay, so do we all see where they're sharing the arc AB? Both my inscribed angles are going to be the same. All right, inscribed polygons and circumscribed. Inscribed polygons, a polygon with all of its vertices in a circle or on a circle. So here are the vertices and they're all on the circle. Circumscribed circle, the circle that contains the vertices of an inscribed polygon. So we have dealt with quadrilaterals. Please remember this one property for a quadrilateral. So looking here, one thing you need to know, when you are dealing with triangles in a circle, this is super important. Your hypotenuse is your diameter of the circle. So I'm going to highlight it. This is my diameter of the circle. If your diameter is your hypotenuse, then the angle opposite to the diameter is your right angle. So you're always going to have a right triangle. So looking at this circle over here, if your diameter is your hypotenuse, the opposite angle is your right angle. All right, this is super important when you're dealing with a quadrilateral inscribed in a circle. We have dealt with quadrilaterals. When you're looking at this, something that you need to know is the opposite angles are supplementary, always. Opposite angles are supplementary. What does supplementary mean?
Equals 180.
Two angles that add to equal 180. So when you're looking at this one, angle 2 is opposite of angle 4. Adding those two together would give you 180. You're going to see this on your homework and on your test. Angle 1 plus angle 3, if you add them together, it's also going to equal 180. So opposite angles equal 180. You will see this on the homework again, and you will see this on the test. So please remember that. Opposite angles are supplementary. All right, useful fact number 1, we kind of already went over this, but you have to remember this because this will definitely help you when you're dealing with a lot of inscribed angles in a circle, and you will see a lot of those. So to help you organize your work, when you have a triangle in a circle, again, if your diameter is your hypotenuse, then your angle opposite to it is a right angle. Okay, this is a right angle. Also, something you should know, if this is your diameter, what is this measure of my arc? 180. It's a semicircle, okay? Don't forget that. Don't forget if your diameter, your arc measures 180. All right, let's go ahead and go to the examples. We're almost done. I know this is really light, so I'm going to try and write some extra information here. Please look at it. I want you guys to look at it before you start writing anything or drawing it. Look how many inscribed angles there are. Try and visualize where they are. See what connects, what the arc is with that inscribed angle, and then we're going to solve these. So, first thing you need to know, this angle right here is 20 degrees. This is 20 degrees. So, if that is 20 degrees, here is my inscribed angle. What is the measure of this arc? What is the measure of x?
40.
Okay, so I'm going to take that 20, multiply it times 2, and that's going to give me my 40 degrees. What else do I know is 40 degrees?
Half of y.
I know. All right, this is also 20 degrees. This is not what it's asking for y. It's asking for the entire thing, but I know that this right here is also 20 degrees. How do I know that that's 20 degrees?
It's congruent to
Yes, it's congruent because they both share that arc. So, y. Y is asking for this entire thing. So looking at it, I need to find what's missing, which is this measure right here that I'm highlighting or drawing in purple. How would I find this angle? How would I find that purple angle? Do I know what the arc measure is?
Oh, yeah.
Yes, the arc measure is what?
110.
Okay, if the arc measure is 110, what's the measure of the inscribed angle?
55.
Good, so I'm going to take that 110, divide it by 2. I'm going to get 55 degrees. So how would I find what y equals?
Add 55 and 20.
Good, you're just adding them together. So 55 plus 20 equals 75 degrees for y. Do we have any questions on this? Again, you have to be able to identify your inscribed angles and your arcs. If you cannot identify that, you're going to have a hard time. So you really have to look at what they're giving you. Questions on A? Yes?
Can you explain how you got 55 again?
Yeah, so how I got 55 was I'm looking specifically at the angle that's in purple. And because they're giving me my arc, which is 110, I have to divide that by 2. So if I'm going from my arc to my angle, it's divided by 2. But if I'm going, for example, for the red, I went from my angle to my arc, I multiplied by 2. So there's a difference between whether I'm dividing by 2 or I'm multiplying by 2. So you have to remember which one's which. All right, let's go ahead and look at B. So looking at B, it's still kind of giving me the same thing. Look at it. I'm still going to take, here is my inscribed angle in purple. Okay, there's my inscribed angle. This is my arc. So if this inscribed angle was 20 degrees, okay, let me highlight it so you know that this is 20. What is also 20 degrees? X is also 20 degrees. Good. X, this angle is sharing the arc. Again, if they're sharing an arc, then you know the measurement. So X is also 20 degrees. Let me just write 20 because they're both sharing it. Now, do I have a diameter here?
Yes.
Yes. I'm going to go ahead and highlight that one in orange. This is my diameter. What do I know about my diameter? What's my arc measurement of my diameter?
180.
Good. This entire thing in orange is going to be 180. So this entire thing right here is 180 degrees. Look at the inscribed angle. If you couldn't see it, please pay attention. Here is my inscribed angle from this angle to this angle right here. I know there's a lot of drawings on there. Well, let me see if I could get maybe a darker color. I'll do it in blue. Right here in blue, and right here is my inscribed angle to that 180. How would I solve for y?
Divide by 2,
What am I dividing by 2?
180.
Good, I'm going to take that 180 degrees, and I'm dividing it by 2. And what's 180 divided by 2? 90 is y. Okay, if you notice that, there's also something else for those of you that noticed it. I have a triangle here. Let me get my green. Here is my triangle. Here is my hypotenuse or my diameter. And this is a triangle in green. If you knew that your diameter is your hypotenuse, then you automatically should have been able to tell that this is a right angle. So there are a couple ways for you to find it. Either you can use your diameter, your 180, your arc measure, or you can look at it and identify that this is a right triangle. So there are 2 ways that you can find it. Questions on B? No? Okay. All right, last slide. Looking at C, same thing. We're almost done. Okay, same thing. I'm going to again have a lot of drawings and colors on here. My arc measures 140, so I know I'm able to find this angle measurement. How would I find this angle measurement?
140
140 divided
divided by 2.
by 2, what would I get?
70.
Okay, good. This is 70 degrees. Now, what's the measurement of this angle in green? How would I find that? Add what together? 70 plus 60 is what? And then what do I have to do with that 130? Good. 180 minus 130, what would I get? 50. Now, if I know that this is 50 degrees, well, how would I find my y?
Times 2.
Good. 50 times 2 is?
100.
So y is going to equal 100 degrees. And then my last one, if I know that this angle is 60, how would I solve for x? 60 times 2, what would I get?
120.
120, and I'm done. So my two answers should be y is 100 and x is 120. All right, looking at the last one. This right here in the center is my diameter. This is my diameter. I know it's not straight.
Yeah, how do we know it's a diameter?
I'll most likely tell you, but this one wasn't that straight. But it is your diameter. All right, what do I know about this? I'm just looking at this as a triangle right here. What do I know about this triangle? Remember, this is my hypotenuse. This is my diameter.
Describe color phase 1.
This angle right here is going to be how many degrees? If I have a triangle that has a hypotenuse as my diameter, what do I know about the opposite angle?
90.
It's going to be 90 degrees. So I already know that right off the bat. And they're both the same, so they're both going to be 90 degrees. Now, next, if this arc is 80 degrees, this is my inscribed angle. How would I find the measure of x? Good, and what's 80 divided by 2? So 40 is x. And then how would I find my y? How would I find my y?
Can't you just add 90 and 40?
Good.
Subtract that from 90.
I can do it that way. So I have 90 plus 40. I get 130. 180 minus 130 is 50 degrees for y. There are a couple ways you could have done this as well. If this was also 80 degrees, this would have been 100 degrees. And then this is my inscribed angle for y. 100 divided by 2 is 50. So there's multiple ways to find these, as long as you can identify which one you're using. Questions, comments, concerns on these? All right, you guys, this is the last lesson. Your test is Tuesday. You do have big ideas homework. You can get started on it.